polymer. Okay? So polymer by definition is you have a monomer. Okay? So if this bottle is a monomer, and if I take hundreds of such bottles and join them, then I form a polymer. Okay? Now these bottles could be identically this bottle, and this bottle could be one bottle, one glass, one something else, one microphone. So take them as differently sized objects, in this case molecules. So what happens? So these four proteins, they are made of long strings of individual building blocks known as amino acids. Amino acids are very simple. I'll also show you that there is no complexity. If you read, you will know. So okay, so there will be a lot of slides I'll go through, but I won't explain slides because, as I said, first you can get those slides, and second, you read any book, any material, you will know what is what. But I try to give you some take home. If you could take them, I'll be very happy. So gene में कैसा ये information stored होता है? That this gene is, so one part I will tell you. I don't know whether I'll be able to succeed. So gene is in the real sense of the word, it's a linear sequence. Sequence of 4 letters, A, T, and G, and C. Okay, and they could be arranged in any number. Okay, but proteins are arranged with 20 such letters. So even mathematically, ये 20 वाला जो है ना, 20 monomer forming so many polymers. So simply, even mathematically, this complexity of this sequence is enormous because it has 20 and DNA has only 4. Okay? Now, DNA, a stretch of DNA is a gene, very simplistically saying, and उसमें जो ATGC, AGG, AAGG, whatever sequence is there, every 3 of them codes for one amino acid. And that is why, and these genes, this DNA, during cell division, एक cell से और एक cell में जाता है, right? एक cell divide करता, so इधर से उधर information is transmitted from cell to cell, and hence from generation to generation. तो ये information जो transmission होता है ना, so that's why this information stays more or less identical, unless there is a disease. I have one example. More or less they stay identical, information. But proteins could have many such differences. How? See, this is something that I was telling you, that this is typically an amino acid looks like. There is an acid group, carboxylic acid, which you know, organic chemistry पढ़ा है ना, acetic acid, formic acid पढ़ा है ना. So ये है एक carboxylic acid, ये है एक amino group, methylamine, right? Aniline. So, and this is a carbon which is called as a, typically it's called an alpha carbon. So alpha carbon, there is one R, there is one hydrogen. This is how an amino acid looks like. And you can immediately make out that this carbon is asymmetric. Because एक कार्बन में 4 चीजें लगा हुआ है, 4 चीजें अलग अलग है. एक है एमिनो, एक है कार्बोक्सिलिक, एक है हाइड्रोजन, and एक है something else. This R, जब ये भी हाइड्रोजन होता है, ये बनता है the simplest amino acid, which is called glycine. You need not remember any names because this is what biology suffers from. प्रॉब्लम वॉइस, ये इसमें बहुत सारे नेम्स हैं and you have to mark them up, you don't have to, at least not for today's, ठीक है ना? So ये है amino acid, and what happens is these are the number of amino acids that one can have, and क्या होता है देखो, these are called polar amino acids. Why? Is because it has a side chain. How could I show you? It has side chains which has some polar groups, SH, OH. So oxygen, nitrogen, see, they are polar. That is why they are called polar. Similarly, there are non-polar groups. Now this group क्या बोलता है, इसको R group बोलता है, ठीक है? And then there is something which is charged. Now by charged I mean it has ionized groups, NH2 plus, NH2 plus, carboxylate, right? So as I was telling, there are 20 commonly occurring our body inside a living organism, but not all. So जिसको हम लोग बना नहीं सकता, वो कहाँ से आएगा? वो फूड सप्लीमेंट से आएगा. So that is why foods are anyway important, but that is why some foods are more important than others, because come to the joining, what I was telling, this joining bottles and all. So if you have दो अमीनो एसिड है, इसको ज्वाइन कैसे करेगा? इसको ज्वाइन करेगा, जस्ट एक वाटर को निकालना है आउट ऑफ वन NH2 ग्रुप, वन COOH ग्रुप. सो ये बनता है ऐसे, maybe I must go here. So this is what a very crucial bond in the entire discipline of proteins. Because you see, I will tell you here one thing. See, these proteins are all available in a living system. But let's say if somebody wants to make a protein in the laboratory, immediately you will get a Nobel Prize if you can make, first of all. Because no one has ever succeeded making a protein molecule in the laboratory. Now, in the laboratory meaning in a chemical laboratory. What you can do, there are technologies available through which what you can do, you can, let's say, some organism makes a protein which is very important. Okay, I give you an example. Insulin is very important. Almost all very diabetic people, there are always, these things, how much diabetic you are. So there are above a certain threshold, all diabetic people, they have to take insulin. Now this insulin kahan se aayega? I have already told you, you cannot chemically synthesize insulin. You cannot. No one has achieved. Okay? And insulin is a very, in terms of protein chemistry, in terms of polymer, it is only a very small polymer. Very small polymer. So by this time, so the problem is, you can probably make a polymer, but then you see, this polymer is not functional. So there comes the next part of complications in proteins. Because the moment it becomes a big enough polymer, which is a thread, now this thread can fold this way, that way, many ways, because it is a long enough polymer. And in nature, you have only one way to fold the protein so that the protein becomes functional. By functional, I mean that it can perform the function that it is supposed to. कोई problem है? If you have a polymer, see, if this is a bottle that could be filled up in water, then it has to have something, an empty space inside, right? So one has to make this a bottle provided there is empty space inside where the water can stay. If there is no empty space inside, then you cannot fill up. This doesn't become a bottle. But if you see from outside, a solid bottle and an empty or water-filled bottle, they would look alike. Right? So similarly, if I have a thread and I have a knot, let's say if I assume few shapes. So let's say if this is the, see, since why did I write this C and A is because there is always this joining through peptide bond going on. One end में there will be a carboxylic acid रहेगा और end में एक, you know कहाँ से कहाँ तक गया, कैसे ये amino acids were joined. Okay. Now what I was telling is, let's say this polymer is not active, but moment it becomes somewhat like this, then it is active. Now this I have drawn in purpose. Okay, I'll show you some protein structures. Then you know what are the intricacies in folding of proteins. So क्या होगा if now this could also fold like, let's say this could also fold like this. Then I am telling you, if this is protein A, then only A prime is active. And if this is A double prime and if this is A triple prime, then A double prime and A triple prime are not active. So there is a question number one. Who controls this to only form this? And which controls this not to form this? So this is forbidden, this is also forbidden. This is a problem, what is called as protein folding problem. It is very important, and nowadays it is really gaining interest. Only thing I tell you at this stage is, since this is a polymer, it is formed by ABCDEFG combination of 20 such letters. Okay. So this is dictated by the sequence of amino acids here. This is one work. This is the only work till date which has fetched Nobel Prize and found to be, I would say, to the tune of 60% to 70% correct. And this Nobel Prize was given way back 1974. Chris Anfinsen is the person's name, who got Nobel Prize on this problem. So here I also raise a case. क्या है देखो, in this discipline of protein folding, I tell you 10,000 or maybe 10 lakhs of scientists are working in the entire globe. But if you call breakthrough, that was only there in 1974, and till date there is no more success, excepting the fact that I know, which I knew 1974, that sequence of a protein, sequence meaning if from N से start करो तो then it becomes glycine, then it is methionine, then it is aspartame, then it is leucine, blah blah blah, ऐसे करके जो इसका एक sequence होता है for every protein, and this is called primary sequence. Okay, so primary sequence dictates how the protein would fold. And then, actually physicists would be the first person. They would say, then give me a sequence, I will fold it. If I don't know how a protein folds, and if you know that sequence is the primary factor for dictating a certain direction of protein folding, तब यही होगा जब if I know sequence of a protein, I'll be able to fold it on computer and tell you this looks exactly like a 8, like the way I have drawn. There's no such success as yet. So if you give a theoretician or a computational scientist a sequence of a protein, can he tell you how the protein will fold? He or she would be able to tell you if